Hello, welcome back to your Math 1 course. We are on lesson 15 now. It starts on page 146, and we're now going to be talking about graphing linear inequalities in two variables. um, so, learning targets, I can find the solution to a two variable inequality by using the graph of a related two variable equation. Given a two-variable inequality that represents a situation, I can interpret points in the coordinate plane and decide if they are solutions to the inequality, and I can write inequalities to describe constraints in a situation. So let's get into it. We're not going to do the bridge, so go ahead and go on to the next page, 147, and the warm-up. So take a moment, pause, read the warm-up, see if you can get number one. Try to do the whole warm-up if you can before you start back up. But if you can't get past number one, unpause and then pause again when you get to the next one. All right, so a homeowner is making plans to landscape her yard to make it more low maintenance. She plans to hire professionals to install astroturf, artificial turf, right? So fake grass in some parts of the yard and gravel in the other parts. Artificial turf costs $15 per square foot to install. Gravel is $3 per square foot to install. It's a lot cheaper to get the gravel than to get the turf. She may use a combination of the two materials in different parts of the yard. So some of her yard might be turf, some might be gravel. Her budget is $3,000. So this is how much she can spend. $3,000. Right, so it wants to write an equation that represents the square feet of gravel. Now be careful on this one and check if you tried it. The gravel is the x. So even though they said turf costs 15 and gravel costs 3 in that order, they want you to start with the gravel and use y for your turf. So since this is all about how much money she can spend, you would say if she spends $3 on her gravel, 3x, that's $3 for every square foot of gravel, because x is the square feet, plus she spends $15 for every square foot of turf, y, square foot of turf, that can equal, she has a budget of $3,000. So if you didn't get that, change that, and then see about graphing from there. All right. So the next step was on the coordinate plane, sketch a graph that represents your equation. Now, I would graph this 3x plus 15y equals 3,000. I would use the intercepts. And using the intercepts just means I'm going to leave off the y, act like y doesn't exist or make y 0. So if 3x equals 3,000, divide by 3, x is going to be 1,000. So I know the x-intercept down here is going to be 1,000. Now, same thing, if I zero out the x or forget about the x part, the y-intercept, 15y, would equal 3,000. This time divide by 15, divide by 15, and y equals 200. I know my y-intercept is up here at 200. So then I just need a line connecting those two intercepts. That's it. So on the coordinate plane, sketch a graph that represents the equation. That would be your graph. What does the point 500, 100 mean? 500, 100 is right here. It's right on the line. So it means if she did 500 square feet of gravel and 100 square feet of turf, it would cost exactly $3,000 because it's right on that line. If she did all, and that's the way this intercept, this 1,000 intercept, if she did just all gravel in her yard and no turf, she could do 1,000 square feet of gravel. That would cost $3,000. Up here, this is saying if she did 200 square feet of turf, she couldn't do any gravel, that would cost $3,000. Then every point in between, those are all $3,000. And you can check that with your equation. If I did 3 times 500, which is $3 for every square foot of gravel, she would spend $1,500 on gravel. If you did $15 times the 100, that's 15 for every 100, that's also $1,500. Then if you add 15 and 15, 1,500 and 1,500, that would give you a total of 3,000. So you could check it just looking at the graph, know that that point would have to equal 3,000. You could do it mathematically, but yeah. So moving on to number 4, what do the solutions of the equation of the line you graphed mean? So that is every combination of x and y, right, the points from the line would cost exactly $3,000. That line represents all the possible solutions. And again, I'll go back, it only shows the first quadrant because you're going to buy a positive number of square feet of gravel and square feet of turf. It only matters there. So every point on this line, no matter which one you picked, if you took the x and y, plugged them into this equation, it would equal 3,000. All right, so go ahead. Look at activity 1. So in the previous problem, we encountered the homeowner looking to update her landscaping to include low maintenance materials. She is considering AstroTurf at $15 per square foot, gravel $3 per square foot, and she may use a combination of the two materials in different parts of her yard. And she has a budget of $3,000. Here is a graph representing some of the constraints. So this is the same graph we just did. Like I said, it shows those intercepts that I used, the 200 and the 1,000, right? And everything in between, and it shows that one point we got. So then for number 1, it gives you this point 600, 200, this point up here, 600, 200. It's definitely not on the line, so we know it won't equal exactly 3,000. So the question is, does that combination of turf and gravel meet the homeowner's constraints? And explain your reasoning. And then choose another point above the line up here for part B and see if it does also. So pause and try that. Okay, so hopefully you tried A and B. So if she has a budget of $3,000, she does not have to spend exactly $3,000, but But that's all she has to spend. She can't go above it. So when they talk about constraints, that's what they're talking about. Are is she able to go above, below? So if we try this 600 again, we know that the gravel, so we take that point, we know the gravel's $3 per square foot, and she's going to buy 600 of that, or that's what this represents. When you multiply those, you get 1,800. $15 per square foot, and 200 square feet of that would be 3,000. So all together, when you add it up, that's $4,800, $4,800. She doesn't have that much to spend. So can this homeowner use that much material? And no, right? That's too much, costs too much. So does this combination of turfs meet? No, it does not meet. No, it can't be done. Too much money. Right? So if we take another point, let's say we use, let's try right here, 950. That one's above the line. And again, if you did this yourself, you might have used a different pair, but as long as you're above the line up here, try those. So this is 950. Would that work? So $3 for, per square foot for the 900 square feet of gravel. That's going to be 27. $15 for every square foot, and she's going to get 50 of that. 15 times 50 is 750. But when you add these two together, you end up with 3,450. And that's a much closer to the, but it's still over. It's still too much. She only has $3,000. So no, that's not going to work either, right? So these 2 points that are above this line, they're spending too much money. What do the points above the line represent? Spending, oh, ing, spending too much money. It exceeds, if you want to be fancy, it exceeds her available budget, right? It goes over what she has. All right, so look at number 2, right? Look at number 2. This time, you're looking at this point. So same thing, try part A, B, and C for that question. Hopefully you tried that before I did it, but so again, we know it's $3 if she's going to do 200 square feet of gravel. That's going to cost her $600. $15 for 100 square feet of turf. That's going to be 1,500. And if you add those, so for this point, that's not right. That's not as much as she has. That's below her budget. That is actually leaves her $900 left over. So is that okay? Could she do that? Well, yeah, she would even have extra money. So yes, it's under $3,000, which is fine. Choose another point, whatever you chose, check it out. I'm going to use school bells. Hold on. All right, I had a little interruption there, but I'm back. So I think we're talking about picking a point under the line. So 650. I'm going to do this one. That would be under the line, right? So, like I said, you could do whatever one you wanted that was below that line, but 650. So that means $3 for the 600 square feet of gravel. That would be $1,800. $15 for the 50 feet of turf, square feet of turf, and that's $750. And when you add those together, you would get 2,550. And again, below, under budget, right? Under the 3,000, under the budget. So if this is the budget line, any of these points down here would be under budget. You would save money. You'd have money left over. This point is closer to that line than this one. Think about distance-wise, and it spent closer to budget. So what do the points under the line represent? That is combinations of gravel and turf that would be below budget or less than $3,000. Yeah. So that inequality, that equation we wrote to begin with, can be turned into an inequality. So we know it was 3x plus 15y had to be equal to 3,000. Well, she doesn't have to spend all of the money, so you could say that could come out to be less than or equal to 3,000. That's your inequality, less than or equal to. All right, so let's look at activity 2. Activity 2, it's a charity concert. A popular band is trying to raise at least $20,000 for charity by holding multiple concerts at a park. It plans to sell tickets for $25 each, and for each 2-hour concert, the band would need to pay the park $1,250 in fees for security, cleaning, traffic services. The band needs to find a combination of the total number of tickets sold and the number of concerts held that would allow it to reach its fundraising goal. So number 1, write an equation that represents raising exactly $20,000. So pause for a second, see if you can come up with that equation. So a couple little things I notice in this one. One, it says for each 2-hour concert. It doesn't matter how long the concerts are. That too has nothing to do with what we're saying. So just for each concert, it's gonna you need to pay the park. So this is not helping out your fundraising. This is going against the fundraising, right? You're paying the park. So think about that when you're writing your equation. So they are going to make, when they sell tickets, they're going to make $25 for every ticket they sell. And T is the tickets, right? But it's going to cost them, they're going to have to pay, so it's going to subtract $1,250 for every concert they have. And again, that's exactly, so we want that to equal $20,000. So that's the equation. Look at next. Take that equation, which was 25t minus 1250c equals $20,000. $20,000. How are we going to graph that? So pause and see if you can graph that equation on here. So last time I did the intercepts. Oh, I don't want that. Sorry. So if I forget the concert, if we just did the tickets, 25 tickets equals $20,000, and you divide by 25, you get T equals, where did I get that? Grab my calculator, hold on. So $20,000 divided by 25, that's 800. So your T, these are the tickets, this is your T, this is your concert axis. The intercept is $5, 6, 7, $800 right there. So what that's saying is if you didn't have to pay for any of the cost of the concerts, if you could just sell 800 tickets, you would raise the $20,000. But we know that's not possible, right? That you are going to have to pay for each concert. So if I look at the y-intercept, it's actually negative 1250 equals 20,000, right? And you do 20,000 divided by negative 1250, you end up with a negative 16. The y-intercept is way down here, the negatives, and I don't have that to graph. So that's not going to help me with this graph. So instead, I want to look at what would be if we held 4 concerts, right? How many tickets are we going to have to sell if we have 4 concerts and want to raise $20,000? So I'm going to look at another possible point. So if it costs $12.50 per concert and we have 4 concerts, times 4, that's $5,000 that's going to come out of what we want to raise, right? So if you add that to the $20,000, you're going to have to sell $25,000 in tickets to make up for the $5,000 that it's going to cost to have the 4 concerts and have enough left over to meet your fundraising needs. So every ticket costs $25, divided by 25, so $25,000 divided by 25 means you're going to have to sell 1,000 tickets. So if you have 4 concerts, you need to sell 1,000 tickets. So that's that point there. So now I can see the trend of the line going up 2 and over 2. So I can just go up 2 more over 2 more, which says if I have 8 concerts, I'm going to need to sell 12,000 tickets. If you sell 14,000 tickets, you can have 12 concerts, and so forth, going up 2 over 2 every time. And then we can make that into a line. So name the possible combination of tickets sold. Like I was saying, every one of those points that you keep, so you could do, if you sell 1,000 tickets and have 4 concerts, you'll raise the money. If you do that one, 14, if you sell 1,400 tickets, you'd have to have 12 concerts. You can come up here. If you sell 2,000 tickets, then you're going to have 24 concerts to raise the money. all of those points on that line will give you $20,000 in profits at the end. All right, so which combination of tickets would mean more money for charity? Well, the first one, hopefully you see, if they sell 1,300 tickets and have 10 concerts, remember 10 concerts cost them money. Well, if they sell the same number of tickets and have 5 concerts, this is the combination that's going to make more money because they're going to put out less for the concerts. But we can always check them because we know $25 for every ticket minus $12.50 for every concert. You can just put that in your calculator, put that in Desmos. 25 times 1,300 tickets minus $12.50 for the 10 concerts. That would raise exactly $20,000, what we're trying for. But if we could have the combination of 25 for the 1,300 tickets, and this time only minus 5, sorry, that's $12.50 times only 5 concerts, we're going to be subtracting less money out of it. So 25 times 1,300 minus $12.50 times 5 concerts, you're going to raise $26,250 for charity. So much more this way. But that should be intuitive. Now, what if they did 1,600 tickets and 16 concerts, or sold 1,200 tickets and 9 concerts? That's not as obvious of which one might be better. So we can just, if they do $25 for $1,600 tickets minus the $12.50 for 16 concerts, how does that compare to $25 for 1,200 tickets minus $12.50 for 9 concerts? And you just plug them into that same formula. $2,500, $25 for every ticket for 1,600 minus the $12.50 for 16. Again, that's exactly, in this one, 25 for 1,200 minus 12.50 for 9, that's 18,750. So we can see this is the better combination. This one doesn't raise enough, or doesn't raise what they're hoping to raise. So 2004, so 25, 2,000 or minus 12.50 and 4 concerts compared to $25 for 2,500 tickets minus 12.50 for 10 concerts. Plugging that in, that would raise $45,000. Plug that one in, that would raise $50,000. So definitely the second option is better. But look at these back on your graph. So if you look back at the graph, that first combination they gave you was 1,300 tickets. So 10, 11, 12, 1,300 tickets and 10 concerts, which is here. Actually changed to red. So we're talking about right there, compared to 1,305 concerts. So 13, and 5 would be about here. So just looking at this line, we knew this is exactly 12. Well, less concerts, you're going to raise more money. So the more money came below the line. The next pair, which was 1,600 tickets and 16 concerts, so 1,600 tickets and 16, again, that's right on the line. That is exactly what you want. Or if you did 1,200 tickets and 9 concerts, that was above the line. And when we calculated that, we saw this wasn't enough money. So this point that falls above the line falls short. Too many concerts up here and not enough tickets being sold. Down here, plenty of tickets being sold and less concerts, so you're making the money. And then the last pair, which was 2004 concerts compared to 2,500 tickets and 10 concerts. Here, which one of those was better? Well, it was this one came out better. We know they're both gonna meet, or they're both gonna exceed the $20,000 because they're on the right side, the side we want. This one's farther away from that line, so we could look at it that way. But sometimes it's kind of hard to tell which one is farther away. So, moving on to number 5, what's the inequality to raise at least? So you would say that $25 for every ticket minus the $12.50, oh, that was T, for every concert has to be at least means that you have to be greater than or equal to that amount. At least is greater than or equal to the $20,000. So we started with 800 when we graphed it, went up to, right, to each time up 2 over 2, up 2 over 2. We got our line that joined all that. So since now it's an inequality, which side would meet our needs? We said it was the side over here. This raises more money than expected. So any of this area, and we shade that in, shows this is what we want. Everything to the right side of that line. All right, so go ahead and do your assigned practice problems that go along with this unit. Have a great day.